Hey everybody, we want to start talking about vector quantities in general. We're going to look specifically at the vector quantity referred to as position, just because that's the easy one to work with. Position is a measure of where you are. It could be where you are in a room, where you are in the state, where you are on a football field, where you are on a grid. That's going to be your position. But in order to determine that, I need to know not just how far you are from some measurement basis, generally the origin of the system, but also in what direction. So what you'll see here is I have an x-axis going horizontally. Okay, it doesn't have to go horizontally, and we're going to find a lot of cases where we don't use it horizontally, but for right now, let's keep life simple. The y-axis goes up vertically. Those are drawn in black, and then I've got a blue grid. And then there are 4 positions laid out in here. All right, so position is measured in units of length. Is that feet? Is that meters? Is it miles? Is it yards? You know, what is it? I don't know. It doesn't matter. All right, so we're gonna be metric for the time being and say that each of these squares is a meter in length. Each square is 1 meter in length. All right, so here's A. So A is going to be atom. So what I might say then is that the position of atom is 4 squares in the x direction, or 4 meters. 1, 2, 3, 4 meters in the x. 1, 2, 3, 3 meters in the y. So I might write it like this. 4 and 3, that's a point. We've done Cartesian points before, right? This is a Cartesian coordinate system or a rectangular coordinate system. There are other coordinate systems we'll get to in another time. So we'll stick with Cartesian. So 4 and 3, but I also want to add in m for meters. A position or a value doesn't have much meaning if I don't give it units. Right? We have to have units. So 4 along the x-axis, 3 along the y-axis. But oftentimes I want to write this a little bit differently. I might write it this way with angle brackets, 4 and 3, and then put meters in there. That's very common. But another way I might write this is 4i hat plus 3j hat meters. Now what does that mean? What is I hat? I hat is what we call a unit vector, unit meaning 1. Go back to your trig classes, we talked about the unit circle. Unit means 1, not 1 meter, not 1 meter per second, not 1 mile per hour, just 1. No dimension there. And the I unit vector always points along the x-axis. And the j unit vector always points along the y-axis. So this is another way of writing this position. How do I get that? Well, let's think about what would happen if Adam is standing right there and I'm at the origin. If I want to get to Adam, I'm going to walk 1, 2, 3, 4 meters along the x-axis. So that's 4 meters in the x direction. I hat says move in the x direction. And then I'm going to, once I've gotten there, I'm going to go 3 meters in the y direction. So 3 meters j hat. J hat is in the y direction. So 4 meters in the I, 3 meters in the j. I could write this 4 meters in the I plus 3 meters in the j. And that's perfectly legitimate. I find it to be a little awkward, but it certainly is legal. Right, so that would be the position of atom. I don't have to go in the x direction first. I could go 1, 2, 3 meters in the j, and then 1, 2, 3, 4 meters in the I, and I'll get there. So I could just walk that way, walk 4 and then 3, or 3 and then 4, x and then y, y and then x, and I'll get to where Adam is standing. Or I could walk right along that line. But if I walk right along that line, how far am I walking? Well, 4 meters squared plus 3 meters squared, that's going to be the hypotenuse of this rectangle. Excuse me, this triangle. That's the hypotenuse of that triangle. 4 squared plus 3 squared is 16 plus 9. 16 plus 9 is 25, and the square root of that is 5. So this would also be 5 meters, but I have to know what this angle is from the x-axis. I always measure my angles from the positive x-axis. I shouldn't say always. By standard, I want to measure my angles from the positive x-axis. I don't need to do that, but that's the usual way. So I would need to know this angle in here. And the way I can find that is I could take the arc tangent of 3 meters divided by 4 meters. Notice 3 meters over 4 meters. Okay, let's take a look at that. So the arc tangent of 3 meters over 4 meters. Notice the meters go away, which they have to. You can't take the arc tangent of a unit of a dimension quantity. 3 over 4, that's 0.75. Turns out that angle is 36.9 degrees. And this is 3, 4, 5 triangles are really nice. We're going to talk about these all through the semester, so you might as well get used to it. So I might say 5 meters at an angle of 36.9 degrees. All right, so you've seen the position of Adam now. Here it is in Cartesian format. Same position. This is what we call polar format. In polar form, I give you the length and the angle with respect to the positive x-axis. If the angle is positive, I'm measuring it in the counterclockwise direction from the positive x-axis. If the angle is negative, I'm going to measure it from the negative, in the clockwise direction, in the clockwise direction. And we'll do that here a little bit later. All right, so the position of Adam, this is going to be our normal format right here for the position of Adam. Okay, 4 meters in the I plus 3 meters in the J. Actually, this is probably a better one. Okay, and I say that because it's faster to write, and I just put the units on the outside. Please remember your units. But the polar form is also very handy to use. So let's not forget that one. These two, don't use them very often, but you're welcome to. That's fine with me. But this is your standard format, this one or this one here. Either of these two, and then this is also a good alternative. All of those represent the position of Adam. All right, and that's a little bit more than I wanted to get to, so let's stop there, and then we'll move on to some more stuff here in just a little bit. Have any questions? Put them in the comments below.